Hello Internet, I'm Dayton Aardema, and today I'm going to be bringing you another do not try this at home, do-it-yourself video. Today's episode, we're going to be building a high-energy directional RF emitter, a microwave gun, using old microwave components. Let's get started. Inside our microwave is a couple of really useful components: high voltage transformers, capacitors, and a magnetron generator. Oh, and also a motor. But what's really weird... Microwave transformers are pretty powerful and also not current limited, which means that they can operate anywhere between 1.3 and 2.0 kilovolts. Don't mess around with this kind of transformer unless you have some sort of safety protective gear. The capacitors too can also be dangerous. Even though it's less than 1 microfarad, this capacitor is still charged with 2100 volts. So be careful and be sure to discharge it with a resistor before using. The final component to talk about is the microwave's magnetron. Magnetrons are one of the most important breakthroughs of the 20th century. The high voltage allows electrons to travel freely inside the chamber, and a constant magnetic field causes them to rotate in a spiral pattern. This is called a cyclotron. The cavity is designed in such a way as to resonate at 2.4 gigahertz. This is the frequency of a microwave oven. The mains inside the microwave are connected to this little component, which is a noise filter. We can see that the voltage on the output is the same as the input. That's because all this circuit does is... That's because all this circuit does is clean up the wave on the input and make sure it's nice and sinusoidal on the output. Here's the circuit fully removed from the microwave and all hooked up. Here's a couple of connections to note. The high voltage output of the transformer goes in parallel with the capacitor and directly into the magnetron. The magnetron also has another wire that goes into the 5-volt coil from the transformer. The chassis of the magnetron needs to be shorted to ground. The ground reference is the iron core of the transformer. Now if I apply power to the magnetron, it will turn on. The time has come to assemble the microwave gun. Since I'm not a complete idiot, I decided to use something non-conductive like wood as the base. If, like me, you want to use more than one magnetron, remember that 2 is going to way overtax any power outlet, which means you're going to need to have these on separate fuses. Now there's no need to reinvent the wheel. We can just use the parts that the microwave already provided to us, such as the waveguide, which is designed to make the waves propagate forward, which is exactly what we want them to do. The horn's a little more difficult, because we need to build that ourselves. It's designed a lot like a megaphone, and it can be used to increase the amplitude of the wave. The easiest way I found to make one is by having 4 long trapezoids, and then folding the shape over on itself, and then just clamping it down on one of the ends. That way there's no cutting or repasting required. Now that we have our safety in order, we're ready to microwave some stuff. You probably know it's not good to put metal in a microwave. Charge will congregate at the points, and can potentially arc to other places on the metal where there is a different charge. Having a powerful RF source like this means that it can interfere with nearby electronics, which I can demonstrate using this AM/FM radio.
He does have the fans, but you're right. One time, a lot more boost.
It stands to reason that you should be able to interfere with the radio signal controlling a drone. Well, not exactly. Drones are attuned to only pick up a very specific frequency. This is why the controllers in the drones don't get confused and get their signals mixed up. Still, I thought I'd give it a try anyway. Once the drone gets close enough to the RF source, the signal just becomes too powerful for the drone to ignore, and then it dies. I would not recommend trying this at home.